So we are going to start Unit 5 today. Unit 5 is about tuned amplifiers. So it's a very interesting unit, and we have only two types of tuned amplifier: single tuned amplifier and double tuned amplifier. And other types are just we are going to study what is what, and we are going to study the concept, the circuit diagram, and the working. That's all. And we have a neutralization technique. So two techniques for neutralization is also discussed at the end of this unit. So exam point of view, as I said already in the class, we have only three questions from this unit. One is single tuned amplifier, one is double tuned amplifier, and one is going to be neutralization techniques. Okay, so double tuned is very big. So we will see the derivation anyways in the online, and I've already uploaded the PDF in the Google Classroom, so you can start downloading and uh, write your assignments, or you can prepare for your CAT. Okay. So first basics of tuned circuit. We have already seen in the oscillators, any tuned circuit will have inductor parallel to capacitor. Okay, so that is called as a tuned circuit or a tank circuit, or it is called as a frequency selective circuit. Okay, so it has different names. So whenever you have an LC parallel combination, you call it as a tuned circuit, because this LC will work only at one particular frequency, F naught. And you know F naught equal to 1 by 2 pi root of LC. Okay, so whenever you're going to have an LC parallel in your circuit will become very frequency specific. So you cannot expect the circuit to work at all frequencies. It will work perfectly only at one particular frequency, F naught, which is dictated by L and C. Okay, and you know F naught equal to 1 by 2 pi root of LC. And if you want to provide a variable frequency to your circuit, instead of putting an arrow mark over L, we always prefer to tune the capacitor, because inductor is already bulky, so I cannot have a tunable inductor in my circuit. The easiest way is to tune my capacitor in my circuit. So by changing the capacitance value, I can change the F naught. So if the capacitance value is going to increase, my F naught will decrease. And if my capacitance value is going to decrease, my F naught is going to increase. So in this way, I can change the frequency of resonance of the tuned circuit. Ideally, you will have only N parallel to C, but I told you practically inductor is made up of, inductor is a winding, it has a resistance, so you will have L in series with R parallel to C. So this is going to be the practical tuned circuit, which you will be studying about in the coming modules. Okay, especially if it resonates at a particular frequency F naught. So if you use this tuned circuit in your corrector side as the load, your amplifier becomes tuned amplifier. If the same tuned circuit is used in the feedback path, your circuit becomes an oscillator. So see how the different applications where the tuned circuit is going to be used in. And compared to conventional common emitter amplifiers with tuned amplifiers, see, common emitter amplifiers will have a very wide bandwidth. You know the bandwidth, the frequency response graph we have done in lab, right? So it will increase, it will be constant for a longer band of frequencies, and then it will fall down. But when you compare that with tuned amplifiers, since tuned amplifiers work only at one particular frequency, you have maximum response only at that particular frequency. On either sides of the central frequency F naught, the gain will start falling down very sharply. So we are going to say that the tuned amplifiers will amplify the signals only in a narrow band of frequency, and the peak amplification happens at the resonant frequency F naught, which is given by 1 by 2 pi root of LC. So any frequencies below the cutoff frequency FL will be rejected. Any frequencies above the cutoff frequency FH will be rejected. So your bandwidth is effectively going to be FH minus FL. So two points you have to consider when you compare tuned circuit and a conventional common emitter amplifier. In common emitter amplifier circuit, the bandwidth is very large. Okay, but in tuned circuit, the bandwidth is very narrow.